Alright, so what I want to show you in this video is how to utilize the solver output and also convert all the information into a graph similar to the one we saw in the lecture slides, but make it fully interactive so that the optimum solution is also visualized. And creating such a interactive visualization may help to better understand especially the sensitivity report that I showed you earlier but went through rather quickly because it is best understood once you see it. So let's continue with our Excel sheet, and what I will do is we had the Bernoullis on the x-axis, so I create the x-axis and call it Bernoullis. And let's say I want to have 30 units there. So I start at 0, and now I create a series which I fill with a step value of 1, and it ends at 30. And next time we have to add the constraints, the cloth and the glue and the plastic constraint. Cloth, glue and plastic. And again, I need to make it fully interactive. To show the basic idea, let's take a look at the cloth constraint. So in the cloth constraint, we have the production coefficient 2, and I call that now A. A times Bernoulli. So A is the 2, but maybe I want to change it later. So I want to keep it very general so that the visualization becomes indeed fully responsive. Plus the one I call B times the nightingale, and that is less than or equal to the maximum available. So I call that total cloth, maybe C. So, but C would be cell G7. So now I want to rearrange this equation to fit a graph where we have the nightingales on the y-axis and the Bernoullis on the x-axis, and then we get our constraint. So I have to rearrange this term and solve for n. So I can rearrange, and then I have Bn equals the total cloth minus AB, and now I divide by the coefficient B, which is the coefficient for nightingales. So in this case, we said this is A, this would be B. And then we get N equals C over B minus A over B times B. So if I want to enter that in Excel, I would say this is always equal to C. So that is always 18. So that's F4. Because as I want to copy down that formula, I don't want that cell to move. And now I have to divide that by B, which is the coefficient for the nightingales, minus A over B times the Bernoullis, which I pick up from the first column. So Now I may have a problem that in order to keep the graph nice, I want to avoid that I hit negative numbers. Because the first constraint has 18 minus 2b, so yeah, just when I copy down this formula, I'm very sure there's something wrong in terms of, okay, so of course I need to also anchor or fix the D7. So you see, because that is always the same, so now I copy down the formula, but I forgot to fix the 2 and the 1. So F4, and that is okay. So now that should be correct. But now you see I get all those negative values. I don't need those. So in order to avoid that we have all those negative values, in other words, I don't want to, there's no need to have a graph where this continues like this. I just tell Excel if this entire equation evaluates to less than 0, then the number is not available, which is hashtag NA/A, but otherwise use this formula. So I just copy the formula without the less than or equal and put it next to it. So now, if I copy down that formula, now you see there are no negative values. Okay, so now we can do the same thing for the glue. That then this formula is equal to the total number of glue, F4 to fix it, divided by, then it's the coefficient here divided by the 4, fix it, minus the coefficient for Bernoulli's divided by the coefficient of Nightingales, and don't forget to anchor it or fix it, times the number of Bernoulli's. So that's the intercept of 5. And now we say again, if this term evaluates to less than 0, then hashtag NA, otherwise use this formula. Okay, so now we can copy this down. Okay, so that worked. And the last is that we now have equal. So now we have the total available for plastic, F4 divided by total Nightingales, F4 minus Bernoulli's coefficient divided by the Nightingale coefficient, F4 times Bernoulli's. And again, now we put around the condition that if this evaluates to less than 0, then say number NA, otherwise use it. So again, the point is to avoid the display of any negative values. Okay. So now I can remove this again. So I go to Review, delete all the ink. Okay. So next we need the area of feasible production. Feasible production. And as I told you earlier, when we go here, when for every x, we take the minimum value as we go up. So that means we just say equals min of the minimum of those three values. That will give us the area of feasible production. So here we see a 5. Copy down. And what I also need is the ISO profit line. ISO profit. Okay. And again, the ISO profit line we derived. We set the total profit, which Excel gives us in this cell. That comes from that cell. Okay. So that is equal to the unit profit of Bernoulli times Bernoulli plus the unit profit of a Nightingale times the optimum number of Nightingales. And again, to match that with our graph, we have to solve for n. So we can rearrange unit profit Nightingale times Nightingale equals total profit minus the unit profit Bernoulli times the amount of Bernoulli, and then we divide by the unit profit for Nightingale, and then we have n total over the unit profit Nightingale, then over the slope given by the unit profit of Bernoulli's over the unit profit per Nightingale times Bernoulli. So here we take advantage of the result that Solver gives us. So let's use this formula. So the total profit is this one divided by the unit profit of a Nightingale. That's this cell. In this case it is cell D5 minus the unit profit of a Bernoulli, don't forget the F4, divided by the unit profit of a Nightingale, again F4, times the number of Bernoullis. And again, I want to avoid negative values, so I'll put in front of that equation an if, open parentheses. If that evaluates to less than 0, then enter a hashtag not available. Otherwise, use the formula, so I can copy the formula before the less than 0. Okay. And I can copy it down. And I can review and I can delete all the ink again. So now I have all the data that I need to generate a nice interactive graph. So let's highlight the array with all our data. Then we go to Insert, Recommended Chart, All Charts, and then click on Combo. Or let's see if we can start, let's start with this line chart. You go to line and then this one looks correct because this one has already the x-axis from the first column. So okay. Okay, so now we have to nicify that a little bit, and to get more space, I'll actually move here to the other side. Okay, so now let's make that a little bit nicer. So I don't really, I can have a, we definitely need axis title. I don't feel like having a chart title, that's unnecessary. So on the y-axis we have the nightingales. On the x-axis we have the Bernoullis. Maybe let's have let's format the axes. Let's see if we can fit in one. Yeah, that fits, okay. And then maybe vertical grid lines. Okay, so now it already looks a little bit nicer. And then I think, what did we have? So the glue was Closworth orange. Okay, let's make that orange. Okay, let's make it maybe a little bit bigger too. Then glue was green, I guess. Okay. Glue, make that green. And the plastic was the old green here. Let's make that blue. Then the isopropyl line, let's make that dashed and black. Okay, and you can see that Excel has the values displayed between the categories. So if you want to make that nicer, you go to Format Axis and you say you want to see everything on tick marks, and then everything moves here now a little bit to the left. The last thing we want to do is the area of feasible production. We want to make that an area. So we change this entire chart and change chart type and go to combo, and then we say again, okay, the cloth constraint is supposed to be a line. The glue constraint is supposed to be a line. It already picks up the colors we gave it. The plastic is supposed to be a line. But the area of feasible production, well, that's actually an area. And the isopropyl line is a line. So now it defaulted back to between tick marks, so let's correct that again. Format on tick marks. Okay. So let's make this area of feasible production maybe yellow, and we don't want it to, let's format this one. Format data series fill, maybe something yellow, give it some transparency. Okay, maybe something a little bit more. And okay, so I think that's good enough for now. So now we have a nice interactive chart. Alex, I don't like that, it's too bright. So format data series, and let's give it a different color. Maybe something that's a little bit more subtle, maybe something like this. Maybe that's okay, and it's a little bit more. It's good enough now. Okay. So the good thing is that now we have a fully interactive, responsive visualization, and we can use that in order to change things. And for example, what would happen if we had, a higher profit for the nightingales? Instead of profit 10, we have now maybe 50. Okay, so now we go to Data, Solver. Everything is still here by default, so we want to maximize this one, but now we have here a new constraint. And now you can see what happens is, if we solve it, okay, you can see that the ISO profit line has changed. And now we would produce only nightingales. So this is already related to the concept of sensitivity analysis. And we will use what we have programmed in Excel in the next video, and let's examine that sensitivity reports a little bit in more detail, and then illustrate using our responsive graph to illustrate what's going on in the sensitivity report, but also the others. But let's just stop here and then continue in another video with the various reports.